So I know somebody will let me know where we finished off. Oh, right. And we talked about meningitis, didn't we?
Yes.
Okay, great. All right. So let me say this. Just because, you know, we're coming up with the last things that are required for this session, I just want to make sure that everybody feels comfortable about what's expected, okay? So Tuesday, when you come in here, you will have the first thing you will do is going to be a muscles lab. You have the word bank. 40 of them, 40 of them. That means if I were you, I'd know a few more just in case, whatever. You will have to show that you know. The way that will be is that you will each be given a little packet with 4 pages of colored, illustrated muscles with different positions, like the torso and the head. There's sometimes different views, anterior versus posterior views. And you will just find the muscles that you know the best, and you will label them. You will only label 40. Okay, I'll give you the directions at the time. So even though you might know more, I only want 40. I'll give you those directions that morning. Okay, but then also on Tuesday morning, let me say this. I'm going to tell you exactly what it's going to be like. You ready? There is going to be a lecture quiz that I would really hope that everyone is seriously prepared for, because if you are not, then 2 days later, when you take the nervous system test, multiple choice test, which, multiple choice, but you're gonna be in trouble if you don't know what I'm gonna ask you to know by Tuesday morning for this lecture quiz test. Lecture quiz on the nervous system. So let me tell you where I will give you all the questions. Ready? For that quiz that you'll take after the muscles. Or I don't know, you'll take one of them first. I don't know first. But anyway, you ready? I am going to have the glial cells. How many are there? 6. There's 6, right? 4 from the central nervous system, 2 from the peripheral. And you will have to match their functions to their names. The glial cells. You will have to or need to match functions from the neurotransmitters we discussed. You'll have to match their names to their functions. Is that fair? Is that fair? Yes. Everybody knows we've gone over those things, right? Okay, so that's fair. You will have to, in chapters 12 and 13, when we discuss any disorder, like Alzheimer's versus Parkinson's versus ALS, polio, shingles, right? You'll need to know the basics of those disorders. This is sounding like a lot, but honestly, it wouldn't be if you had this clear in your notes. This would not be that much. It shouldn't be. Make sure you could match. Make sure you could match the names of those bacteria and when they're most suspected in meningitis. For example, neonatal meningitis is most often caused from what? Group B strep, Streptococcus agalactiae. Where in toddlers, what do we most find? Did she say no? That's right, Haemophilus influenza B, right? Which is the predominant now all through any of the ages, Streptococcus pneumoniae. But what's the one we worry about with young adults? Neisseria meningitidis. So that's I just gave you the answers to those, okay? Now look, there's something else. And again, you're going to need to know this by Tuesday. Because if you know this by Tuesday, those things are a lot of the test questions on Thursday. So if you know it by Tuesday, you'll do well on the quiz. And you'll be in a big head start, more than, a long way to getting there for Thursday. There's one more thing you're going to need to know. We haven't done it yet. You ready? 2 more things. We're going to do it today. I'm going to talk about different areas of the brain. Frontal lobes. What were these? Look. So we'll talk about areas of the brain, and you have to match the functions to the areas. Why would that be important for you to know? Why are we going to spend some time on that today? Because different areas. It's different areas. It suggests to us that the different areas of the brain have very different functions they're carrying out. And that's true. And so we'll learn which ones they are. But why do we care?
Because some things affect certain areas more than others.
So if you have a stroke in the parietal lobe, I would want you to know what symptoms are being exhibited in that patient. When there is a trauma to the frontal lobe, I want you to know what to expect your patient not to be able to do. When you have an injury to the back of the head, the occipital lobe, I want you to understand that's why that person is blind when their eyes are perfect. But they're blind because we actually don't see. We receive signals with our eyes, but we see with our occipital lobe. That's where it's processed. So if you get injury to the back of that, do you see what I'm saying? I want you to know, not just for academic purposes, I want you to know so that you understand when your patient has a tumor, a stroke, a bleed, a traumatic injury, something going on in that particular area of the brain that you hear about, you'll know why they have lost what they have lost. Do you get what I'm saying? So you will need to match those functions. I'm going to tell you, if I were you, I would study my note. I would take my notes and everything I just told you about matching functions to the areas. I would make those notes tonight, and I would look over them quite a few times before next Tuesday. Let me tell you, the last one are the cranial nerves. Guess what you're going to have to match to their names? Their functions. You are going to pass the test on Thursday if you know these by Tuesday. I'm not saying you're going to get an A or a B, but you're going to pass the test if you know these things that I just said to you. I think that's a fair thing to ask. It's Thursday, you have until Tuesday. I know you have lots and you're busy as heck, but you do want to have these by Tuesday. Okay? Do you have any questions from you? All right.
So our last thing in is on Thursday?
It's on Thursday, but Thursday, see, I can't give you all new information and expect you to test on it that day. So we're going to finish up all the lecture notes by Thursday. By Tuesday afternoon. Tuesday morning probably. But we're going to finish those up. We're actually going to look at brains and dissect eyes on Tuesday. I'm going to give you the word banks for the areas of the brain that we talked about today. I'm going to give you the word bank, and I'm going to give you the word bank for the ear and the eye that we talked about on Tuesday. I'm going to give you word banks so that you know exactly what those labs are on Thursday. But Thursday is really just a testing day. On Thursday, we will all take our nervous system test together like we did this morning. We will all go over it together because on the nervous system, there will be deeper insights and disorders. And I would want you to know if you missed something, what the right answer is, right? Then I'm going to let you all take a break. Really, if you have as much as 2 hours to take a break before you come in and sit for that fun exam, which is a 50-question multiple choice test. Counts as a test grade. What's on the final exam? Some of you look disgusted that I've asked it for the 100th time. But it's because I always use it, and it's okay because I get, Megan and I were talking about it this morning, how people have a lot going on in their life. There's a part of your brain that takes over when you are stressed. We refer to it in medicine as the lizard part of your brain to survive. It's reptilian. But when you are stressed, you're not hearing what's being said because the cognitive part is not getting what it needs. So the best way for you to perform is to try to de-stress your lives. Oh yeah, like right, that's easy. but try to be prepared as you go. Can that relieve stress? Not be a procrastinator. How many of us are procrastinators? I'm the first one that raised my hand too. That adds to our stress, by the way, guys. So we're doing it to ourselves. You know, so things that you know you can do to bring that lizard part of your brain, make it calm down so that the frontal lobe and the cognition areas of your brain can actually work, right? Did I answer what you said? What you asked?
I didn't ask you.
Oh, okay. I thought you asked me something. Okay, yeah. So anyway, that's what we're doing. That's what we're doing. And I know that sounded like a lot, naturally, but I really would. I would make those notes like that. And I would make sure that for each of those sections, when I heard something, I could match its function. Right? So let's keep going with our study here. We had talked about meningitis, and yes, we know that actually the most common cause of inflammation of the meninges is actually what? Is it bacterial or viral? It's viral by far and away. It's way more common to be viral. But viral meningitis doesn't have as high a mortality rate as bacterial. And do we need to be very sure that we know what we're dealing with? Yes, we need to have a definitive diagnosis. All right, so I want to let you all know that the brain ventricles, when we talk about ventricles, and again, this is a region, an area of the brain, isn't it? These ventricles, the way you're seeing this lateral view and this anterior aspect view, they've kind of been superimposed as to where they are, these ventricles are. There is a right and a left one, but then there's also a third and a fourth one. So they're considered to be these four regions of ventricles. And when people do a dissection of a human brain, it looks like they do this dissection. Is this a transverse section? Y'all would know what that meant, didn't you? It looks like you've got these four holes in your brains. Now, obviously, you don't have things for no reason. They serve a function. These ventricles that you have here, that you're seeing there on that dissection, these ventricles are where the cerebrospinal fluid is irrigating, cleansing, stabilizing the chemistry of the nervous tissue, and keeping a chemical balance of this nervous tissue. So when we look at cerebrospinal fluid, and people call it CSF, right? CSF, we know that some of the functions of the cerebrospinal fluid, section on the next one, the functions, it sounds like it's a joke when you hear it floats your brain. I didn't write that, that was from your textbook, but floating your brain. But actually, it is very protective because it is being surrounded in this fluid. If you hit your head even like that, like, right? If I didn't have, some stability there, my brain would hit up against the inside of my skull, wouldn't it? But it is protected. It is floating your brain. It's cushioning it, and it's keeping chemical stability. We make a certain amount of CSF every day, and then we have to reabsorb a certain amount every day to keep that balance. We said when you have too much, then it's called hydrocephaly, isn't it? How would I break down? Are there any such thing as big words or just little words? That's what hydro means. Cephaly means brain. What's encephalitis?
Inflammation of the
brain. That's exactly right. Encephalitis, inflammation of the brain. So we know there's no such thing as really big words, and you don't ever give up on something that you're reading. Think, how can I break this word down and maybe make some sense of it? Okay, so great. It's keeping that stability. Okay, so here's what I'm going to want you to know about the medulla oblongata and the pons. When we talk about, well, I don't really like this picture or that one. Okay. All right, I'll go back to this picture. So this is a mid-sagittal section. Would everybody know what aspect we're looking at? So if you were looking at through my skull, through my, all the supportive structures and looking at my brain, if I took a dissection right through those hemispheres, and then this is the frontal lobe, right? Parietal, occipital. So if I was looking at a mid-sagittal
cross section. This is the medulla oblongata, and this is the pons. Now you have tons of pictures of these in your book, different aspects of these in your book. I want you to know that this is actually what we can sort of think of as the brain stem area. The brain stem, y'all have all heard of that, haven't you? Now, what I want you to know from the pons and the medulla, though, is this idea that this is the area that controls respiratory and cardiac functions, as well as other functions, but respiratory and cardiac, and let me go ahead and tell you, consciousness. So when somebody has damage to the brainstem, they might be in a what? Coma. Really. So brainstem, respiratory. They might also be on a what to breathe? Yes, a ventilator. They may be on a vent. Cardiac function too. So we understand this is an important area, don't we? Okay. So the pons and the medulla oblongata. Guys, this we said was the frontal, just to give you aspect here. This is your eyes are here, your nose, you know, so just to give you kind of aspect. So this is the occipital lobe. Beneath these lobes, frontal, parietal, occipital, and that we're looking at the medial aspect of the temporal, right? There's something here that looks very different, doesn't it? This little area here. This is actually called the cerebellum. Now, the interesting thing about the cerebellum, and I would want you to know, is that it has 50+% of the neurons in your brain. So it actually has a ton of them, but the lobes make up most of the volume, right? Here's what and the only reason I'm telling you that, I'm not going to ask you about 50%, I'm not. But I want you to know this. There's a lot we don't know about the cerebellum. There's a lot we don't know. There's some things we do know, and what we do know is that as information passes into the brainstem and has to move up into the lobes, we know that the cerebellum plays roles in sensory perception, and it plays roles in equilibrium and balance. So we know that part, but I think there's a lot that we're going to be finding out in the next short while, right? So I just want you to know we do know that part. FYI, which means what? I'm not going to ask you a question on it, but FYI. Y'all have all heard of autism, haven't you? Now, I would like you to understand that autism is a huge spectrum, too huge. Way the heck too huge. So when I'm talking about autism, I'm not talking about the people who have been declared to be labeled autistic that have PhDs. I'm not talking about them, okay? I'm talking about the autism where there is no communication skills happening, where there is heightened sensory and abnormal sensory things happening, no communication, and sometimes, you know, actually you see little kids sometimes that will be repeating motions, and you can just tell they're overwhelmed sensory-wise, and sometimes we'll even like hit their heads against the wall, you know. So I'm talking about those, not the others that I think have been given a label, okay? But the ones that are autistic, that have lost communication skills, that have lost the ability to like make eye contact or bond or whatever, their cerebellums are significantly smaller. They're different and anatomically. If they're different anatomically, when it suggests something to you that the function's different from there, yes, it would. It would. And they are. So that's just FYI. Lots to learn about that, right? Lots to learn. So good, the cerebellum. And these are different cuts of the cerebellum that you actually see. And then I'm going to tell you about, if I skip it, are you going to be responsible for it? Huh? No, I've never asked you things I didn't talk about or were in deeper insights or disorders. I haven't. Now look, here's what I do want to tell you about, and I'm just going to use this picture because I'm tired of going around from different pictures. So I'm just going to use this picture. You ready for a lot that I'm about to talk about? And again, we said this is a mid-sagittal section. Is there anybody in this room that doesn't know exactly what we're looking at? What aspect? Please tell me, because it's okay if you don't, but just please let me know so we can clarify. Okay. So we're looking at this, and we said that we've got spinal nerves, we've got cranial nerves, 12 pair that are going to be coming off this spinal nerves that are going to be coming, and they're sending information in. Sensory ones are sending information in. It's going to be integrated by this area, and information will be moving out as well. Fair enough? All right. So we said this is the brainstem area, the medulla oblongata. Say it out loud. And this one is the Pons, and information's coming in, and obviously there's going to be this this divergence of how that information talks to neurons, because we see on gross anatomy that what this tissue looks like. We've got a human brain for you to look at, and some sheep brains for you to look at, and we see what it looks like. But what we understand is this: we can't see it at a cellular level, but we know that this is just composed of many cells. Have y'all heard of white matter versus gray matter?
Yeah.
Write down, because you will need to know this. White matter versus gray matter. White matter is what when we see it, it looks white, doesn't it? Is why we call it that. White matter. You know what that really is? When you see tissues that look like this white matter, what you are looking at are axons that are myelinated. So why does it look white? Because myelin is what? Myelin really is fat, and it's white, and they're condensed because they're really packed. So you know what you're looking at when you look at white matter? You're looking at the highways of signals where they're traveling along the highways. Guess what gray matter is? That would be a good guess from what I said, but it's actually the somas of the neurons, and the somas of the neurons are the what? The bodies of the cell bodies of the neurons. That's the gray matter. Isn't that cool to think about? Mm-hmm. So when y'all look at your dissections, that's what you'll be seeing. Now, just to give you a glimpse here, so look at this cerebellum here, and this has been dissected, hasn't it? And see how this looks white? This white of the cerebellum, this area called the cerebellum, is actually called the arbor vitae, or vitae, some people say. So arbor vitae, this is going to be, what, do you know why it's called that? Because it looks like what? Arbor means what? Trees. Doesn't it look like a little tree? The stem of a tree and the branches of a tree. But you know that white matter is actually what? Myelinated axons. That's the highway of how signals are getting there, and then how signals are being moved back down, isn't it? Okay, whatever. So I wanted to tell you all that, just to let you know. But let's think about how those signals are coming in to our brain, okay? So signals are being received, they're moving up through this brainstem area. And as they move up through, this is called the midbrain, but as they move up to this area, and I want y'all to look at this area here, it's called the thalamus. No, don't pay attention to the title at the top, because I'm just using one picture. But this is called the thalamus. I want y'all to know that the thalamus is actually the gateway. This is called the gateway, and what I want you to know that. It's called the gateway to the cerebrum. Now, you might not have heard me use the term cerebrum, but I need you to know that the cerebrum is all of the lobes. Do you see how all these lobes are here? So the cerebrum consists of all of the lobes. Tell me the lobes again. Exactly. So they make up the what? Cerebrum, which is not to be confused with the cerebellum. Are you good? Okay. So I told you, and actually if you look at this, you can see anatomically that these highways take you up, and this thalamus really is the gateway to these lobes, isn't it? And some people call it the gatekeeper. Some people call this the gatekeeper because we know some things as they move in, they actually are going to be, it's going to be decided how you're going to act on them. do you know what? And this is really true. So if people are trying to keep up with this in the book, bless your hearts, seriously. But okay, because I'm trying to give it to you here. But okay, it's whatever you want to do. So this is why if the gatekeeper wasn't working, if the thalamus wasn't working, I would be and you would be little jelly messes on the floor. We wouldn't be able to, because there's a ton of stuff going on. There are people asleep. There's people not paying attention. There's people paying attention but wiggling. There's lights flickering. I would just be a mess because so much stuff would be coming in and all of it would be coming in and I wouldn't be able to handle anything. Nothing. So some things your brain has to make sure that, you know, you're getting what you need so you can function, right? It would be the same thing. Guys, how many of you have heat pumps or something that turns on at night, it clicks, make a noise, right? Makes a noise, right? So it does. Or you live close to a highway like I do, where trucks and, you know, are going up and down. But do you wake up every time a truck goes by at night? You wake up. What happened? Why not? Because your thalamus is controlled. There's some things that you can let go and you don't have to sense, right? And other things that you might need to be alerted to, like you don't hear any of that, but if your child rolls over, then you heard it, didn't you? Right?
Husband didn't hear it, but
Yeah, that's, listen, I know you don't want to. I was hearing a ding, ding. I was hearing this in my house.
what does he watch?
So I was thinking, what is that noise? And I was first hearing it like at night. I heard it, and I thought, there's no luck, right? That's never made that, like that little thing, never made that. Oh, what is that noise? And I thought, I'm hearing it through the floor, and it's something else. And I didn't know where it was. And then I heard it one day, and my husband's watching the ball game, and I was like, actually, there it is again. There's that noise. And so the other morning, no lie, this happened 2 days ago. The other morning, I heard it again, and we're sitting, it's like 4:30 in the morning, we're drinking coffee. I said, that noise is coming from you. You are the denominator. I said, and he said, what noise? There's no noise. There was no noise. I said, there was. There was a noise. And I told you that I was hearing something go off. It was going off every hour. So I really went mad. But anyway, he never even heard it, but it was his watch. It was his watch and he fixed it.
So your thalamus, like, make sure that you don't overstimulate. It's like, so
it's controlled. It's controlled. Because in our world, are there things that threaten us?
Yes.
Or are there things we need to be alerted to? But in our world, isn't there also a lot of stuff that we just need to be habituated to?
So you don't have a sensory overload.
Exactly. So it is the gatekeeper. It is the gateway. It's the gatekeeper to the cerebrum. Do you see that? All right, now, let me say this. So you would say that if you look at a function of the thalamus, that's how it acts, right? Right below the thalamus, and because it's right below, it's called the hypothalamus. It's called the hypothalamus. Let me tell you what I want you to know about the hypothalamus. I'm just going to do it all from this slide. What I want you to know about the hypothalamus, which is right below the thalamus, right here, this little area, and then there's a little stalk of tissue below it. This, it is ruling and rocking your world. Let me just say that. Now, obviously, I'm not going to ask you a question about what's ruling and rocking your world. But if I ask you a question about what area is actually determining your temperature, whether you are thirsty, whether you are hungry, whether you feel full, whether you want to have sex, that your libido, your metabolism, all of those things. So they sound like important things. Mm-hmm. Guess what's controlling them? Your hypothalamus. Your hypothalamus, which is different than the thalamus. Now, y'all might be saying, but what do you mean? That's here, this is here. That doesn't look like anything distinctive. Yes, it is. So it's the hypothalamus. Now, how it's carrying out many of its functions, how it carries out many of those functions is that it sends signals through this little stalk of tissue to a little pea-sized, little pea-shaped gland called the pituitary. The pituitary. Have you heard of the pituitary?
Yes.
So here's what you want to write down for the pituitary. It's helping to rule and rock your world because it's sending out 8 hormones that are going to have functions as varied as growth, reproduction, milk production. I'm trying to think of, metabolism. So it's going to control all those things, but it's not going to do anything until it gets a signal from where? Are y'all impressed with that deep part of your brain? You should be impressed with that deep part of your brain. Yes, Ray?
So you said the hypothalamus and the
Well, I can't hear you.
So the hypothalamus is signal to the pituitary
Yes.
and the pituitary goes.
It carries out all those functions because the hypothalamus told it to. Yes, yes. And the hypothalamus also sends out signals to make it stop when it needs to. Because what did we say is the feedback that keeps us in a state of balance? Negative. So the hypothalamus is sending signals out to make things go up, but then it's sending signals to the pituitary to stop when it needs to. So really, you could say it's the hypothalamus that's ruling and rocking your world, and what's helping it to carry out all those functions? The pituitary gland. Why do I care that you know that distinction? Because if it's a pituitary hormone that's the problem, this is just this is just a preview of what's coming in that first chapter in the AP2. If it's a pituitary hormone that you're deficient in, is it necessarily because the pituitary gland is at fault, or what might be at fault? It added an entire another layer of our understanding of how the endocrine system functions by knowing this. And that's important for you to know. Not now, but just going forward about why we want to know this. Okay. So, do we know what the thalamus is? Do we know what the hypothalamus is? Do we know what the pituitary is doing?
Yes.
All right, now I want you to look toward the caudal, which is toward the back or tail, if you will, toward this back area. And there's a tiny little spot called the pineal gland. Some people say pineal gland. You'll hear it depending on what site you do pronunciation. Anyway, I want you to put in parentheses is your third eye. That's what I want you to put in parentheses. You know why it's called your third eye? I think I told you this. Why is it called your third eye? Is it hot in here? No. Your what? Okay, you got, did I say you see with your eyes?
Yeah.
What do you do with your eyes? We're going to talk about this here with your eyes. What'd you say?
Sensory. Receive sensory.
They probably don't like people doing that, touching those. With your eyes, there are specialized cells that are innervated by light waves. You're not seeing, they're receiving signals from light waves. And in the middle of your eyes, deep to the middle of your eyes, and where those optic nerves meet back here, right behind that, is a little area called the pineal gland. And here's what, or pineal gland. This gland is called the third eye because it is also going to be affected by light. And it's also being affected by light, natural light. Now, in that response to that natural light, what are you releasing from this gland? Serotonin by day that gets converted, that changes its chemical structure because it doesn't last forever, gets converted to what by evening? Melatonin. This is why it's considered our third eye, because the eyes are affected by light, and so is this gland. This is why I said we should be up to see the sun come up every morning because we're animals, and it affects our serotonin levels, keeping them on a 24-hour circadian rhythm of where they need to be. So that's our third eye. Any questions for me about the function of this gland?
So if people work third shift, would that like affect them?
Absolutely. So people who work third shifts, and there's some things in our society now that people need care all hours of the day and night. We probably don't need Walmarts being open all night, but we have hospitals and we have stuff that people need care. But honestly, you know why you get paid that shift differential? Because you're going to need that money for your medical expenses later. No, not really. That's not what they say. But you better be saving it aside, unless you're being proactive in doing things that can maybe help you out here. So let me tell you what you can do if you have a third shift, but they know this messes people up. They know it does, which ends up suppressing your immune system over time, which would end up causing more chronic disease, more incidence of certain diseases, right? So people who work third shifts should make a serious effort to create a cave when they get off, meaning no light coming in. Because actually, any of those of us that are sleeping with TVs on, or how many of you are sitting with TVs on or your phone right beside you, they even think that digital alarm clocks, that's probably too much. Like, we need to keep a cave-like environment. And then those people who are working third night shifts should probably get those lamps that are simulated simulated photo light lamps that they give people when they have seasonal affective disorder. They prescribe those lamps to be exposed to. Did I talk to y'all about that? Oh, I didn't. Okay. Well, thank you, Maya. So thanks, Maya. So I thought I mentioned seasonal affective disorder. So one of the treatments, not drugs, is that chemotherapeutics are always going to have an effect, and you're going to have to counteract that effect, and then you have to take another one to counteract that. So the best thing to do, and they know this, is to treat with phototherapy. People who have seasonal affective disorder, people who work third shifts should get those lights and make sure they're being exposed to those lights when they wake up. You know, even if they're waking up at 3 in the afternoon or 4 in the afternoon, expose themselves to those lights even during the night shift. You know what I'm saying? And try to get their bodies to stay on a 24-hour circadian rhythm. We know it can help their health. But honestly, that is, they pay you extra because they say it's inconveniencing your life and, you know, whatever. But honestly, I've heard many people in the medical community who I have a ton of respect for say that very same thing. They should be saving that extra money for later because they're going to need it in medical costs. Okay. I like the night shift better in the hospital, actually. I think I've talked to a couple of y'all about that. But I'm not a night person. I definitely know I'm a day person, but night shifts are kind of important. But here's the thing. I do wonder sometimes about like why we have certain things open, like that are not necessary to be at night. Okay. Yeah. Did I have a question? No. All right. So could you all label right now, just from this one, could you label the medulla oblongata? Could you label the pons?
Yes.
Could medulla oblongata? Pons. Could you label the thalamus? So y'all pretty much got the brain anatomy down. But let's continue with our functions, okay? And knowing functions to certain areas, okay? So I think I've got some better things for the lobes of the brain. So here, the cerebrum. What do we say? It's all these lobes, isn't it? It's all these lobes. Now, a lot of people don't really know why, because you could look at a skull, and you all knew where the frontal skull bone was, right? And the frontal bones actually fuse, you know, as you age. So it becomes one frontal bone, right? The parietal ones don't do that, but they come suture together, don't they? So, so we did that. But this frontal area, let me tell you what to write down. Write down personality. Write down personality. Write down frontal lobe. Write down personality. Write down cognition, which is thinking and critical thinking. Judgment. important things, aren't they? So if somebody's got frontal lobe dementia, what have they lost? Who said, a couple of y'all said that themselves. That's exactly right. They've lost themselves. And family members, this is hard on family members. When they have a loved one who has frontal lobe atrophy and they have lost themselves. They're not even themselves. So, right, frontal lobe. Parietal. This parietal lobe, say parietal. Some of y'all had some problems with stuff. Y'all notice I wasn't as mean as I said I was going to be about the spelling last time. Yeah. Yeah. Yeah, I was mean, or yeah, I wasn't as mean. Yeah, you were not. You had to be close though, really close. Okay, so but the parietal lobe is sensory. So if you feel a tick crawling on your foot, guess what lobe got that information and sent that information to you to know? Parietal, right? You feel a kiss on your cheek? Right. Sensory, so sensory, parietal. Occipital, I want you to know vision. This is where we actually interpret sight as the occipital lobe. This is why we can have injury to the back of the head. You can fall. How many of you fallen and hit the back of your head before and it just rocks you, doesn't it? It's awful. It's like, and for a second you are blind, if that's ever really happened to you. But some people are permanently blind after that injury. That can be permanent. So, occipital. This temporal lobe is being pulled apart so you can see the insula, which I'm not going to ask you about. But anyway, this temporal lobe is where we think of hearing, some smell, and even an area that is referred to as the limbic system. Have y'all ever heard of the limbic system? The limbic system, and you'll see a superimposed thing of the limbic system. The limbic system includes the hippo, and you won't have to label this where it is, but I want you all to know what this is responsible for. The limbic system is composed of the hippocampus and the amygdala. Have y'all heard of those two areas? Mm-hmm. No? Okay, so the amygdala. This is going to be in your notes in just a minute, and I'm sorry, I just thought it was maybe even easier. Here it is. Okay, so here it is. And y'all kind of can see here, but it's really like this is, you're seeing it from mid-sagittal section. But if we were to, and you only seen the medial temporal, but this is really kind of thought of in this temporal region. So if you write these down, amygdala and hippocampus, what I want you to know is that the hippocampus is memory. So memory in this area, memory. And the amygdala, which is this little funky looking little region right here, this is emotions. Human beings, y'all have all heard that human beings in the animal kingdom have the longest developmental period of any other animal, haven't you? We have the longest time that we're dependent, and the longest time that we're still developing to maturity. The amygdala is often not completely mature until the mid-20s. So, and that's for your emotional centers. Have y'all heard of emotional maturity? Right? How many of us that remember, I know, I'm probably still doing it, but anyway, where you just, your emotions take over, your amygdala gets hijacked, and that's what they call it, amygdala hijacking. Your amygdala gets hijacked, and you just don't act on it the way that you wished you'd act on that situation. You get what I mean? Well, those situations typically start to be less after about the mid-20s. It actually is kind of sometimes referred to as emotional maturity. But we know there's parts of this thing that doesn't even mature until then. And the sad thing is, our people they have a lot of independence in their teens and early 20s, right? Even procreating, right? And doing whatever, but still not at a mature level themselves. So this can affect. It really kind of can. How many of you have ever known somebody you thought, gosh, they've really mellowed? Mm-hmm. Right? They've matured. It's that. This is physiological in some respects. And the hippocampus, we said, is memory. So is that good? Now, there's another, and this is going to be on a better picture in just a minute, a better picture, but there are two more areas I want you to know about. Lord have mercy. Let's see if I can find it. Just a brain is fine. Look, there's a little area, and this is not on this slide. It's not on this slide, but the little area is kind of here at the frontal, at the this frontal lobe that includes this dark violet and this light blue. This dark violet area, now you don't have to write this down, but you do need to put it with your frontal lobe, sorry. You need to put it with your frontal lobe functions. This is motor, wanted motor, voluntary motor function. So that y'all are taking notes, where is that information coming from? The what? Frontal. It's voluntary motor functions. There is a little area down here at the base of this motor functions in the frontal lobe called the Broca's, B-R-O-C-A. Broca's area. This is the motor function for speech. For speech, you actually have to use muscles that you're controlling to make sounds for speech, don't you? Now, back here at this, it's really at the back part of the temporal, kind of superimposed on the parietal, is an area known as the Wernicke's. Y'all are going to see these spellings in a second. Broca's and Wernicke's area. This is for language interpretation and planning. So, if somebody has a stroke and that bleed has actually hit in an area right here, what might that patient not be able to do? Speak. But are they going to know how to write you a note?
Yeah.
Yeah. But if they had it back here, they might be speaking fine, but it's making no sense. It's just gibberish. I didn't say gibberish. Aaron did. But yeah, gibberish. That sounds something just. But yeah, it's just not making any sense, is it? So again, these are why we want to know these areas, because then when we see damage from our scans that our patients had, or it's listed in their reports about what they had, we know what to expect and maybe what not to expect.
So
right?
it's between the parietal and the temporal?
Well, so I'm going to show you a picture of it. You're going to see. So the Wernicke's area is right here, and the Broca's area is right here without this being pulled apart. Is
So
about
they're
right
both
here.
in the temporal.
No, the Broca's is really at the base of that frontal, at the base of that motor thing of the frontal.
And then where's the Wernicke's?
What'd you say?
The Wernicke's? Where's that?
The Wernicke's.
Wernicke's,
The Wernicke's
sorry.
area is right here. Y'all are going to have a picture of it in just a second. Just a second. So now this is showing you some of the things I just told you. Is that right? Okay. Now look, I do want to say this. On the temporal area where we said emotions, emotions and stuff, then you have to send that, then signals get sent by neurons to the postsynaptic neurons to the frontal lobe as far as planning how you deal with it. Right? So, when you are talking, when you've got little toddlers, how many of you have known toddlers, or you've had one that threw tantrums? Some of you have right now. And that's all really normal, isn't it? For them to have that. But it's just that they don't know how to act on that. So, they don't learn how to act on that. But it's all so normal. It can be so normal for that to be happening. And then they will learn. That they will start, the communication will get better, and they will learn. That we've learned most of our stuff by behavior, right? Behavioral things is how we learn. So anyway, great. All right, so I talked about white and gray matter. Limbic system is showing you there. I do want you to know about EEG, exactly what it stands for. It stands for an electroencephalogram. Electro meaning that you're going to see electrical currents, how they move through the brain. And it's going to be on a little chart, isn't it? You're going to get a little graph of it. So an electroencephalogram, it's going to be recording these. Now, look, we don't get enough time for you, for me, I don't think, for you guys to, learn each of these different wavelengths, but you can see that there are different wavelengths. I won't ask you about them. I just want you to know that these are being measured on an electroencephalogram. They're being measured by their amplitude and how quickly they are, how quickly they're happening. You notice this one, the peak to peak is kind of far spaced out here. So they're all very kind of different. And all of them represent different kinds of activity, brainwave activity. So that's what they represent. And that can be done. And a neurologist knows how to read these and knows this stuff pretty well, right? Now, or hopefully very well. Way better than me, because that's about all I know. Okay? So I've never even seen, that's one of the things I have never even seen anybody have is an electroencephalogram. I've gotten to see a lot of surgical procedures, but I've never even seen a basic one of those, and I'm actually kind of glad I haven't, because it means so far none of my kids have needed one, or me had needed one. But anyway, and I just never watched a patient have one. Has anybody in here? Have you had it yourself? Okay, so yeah, yourself. But you see it. Yeah. So a neurologist is typically going to do certain stimulations during this and watch those wavelengths and see how those wavelengths are happening. Sometimes they really want you to come in tired. Is that right? They want you to bring them in tired. And sometimes they're going to use lights and stuff to try to stimulate certain things. And a specialist would know how to interpret what's going on with those wavelengths. What I want you all to know is that about sleep and how we can use EEGs. We can use EEGs to help us to know if somebody is in a good sleep pattern. Here's what a couple of things I want you to know too. There's something called non-REM and REM. What does REM stand for? It probably is right behind me. Yes, it is. So what does REM stand for? Rapid eye movement. So non-rapid eye movement, rapid eye movement. What I want you to know is that that sleep, sleep's a weird thing, isn't it? Does anybody do any of you remember being really little when it first dawned on you that you were about to fall asleep and you started worrying about what sleep was? I actually remember that. I remember it very, very well. And I remember fixating on it for a little while, some days or something. But anyway, and I must have been really, really little because I was still in bed with two of my siblings. So I know I was little. But anyway, sleep is a weird thing. And let me say this to you guys. We've learned so much about it recently. Dr. Paul Surratt was one of the first sleep specialists in our country. He was at UVA. He started one of the first sleep clinics. Y'all have probably all grown up knowing that there were sleep clinics in all these little community hospitals even, right? Have you? Have y'all grew up knowing that you could go get a sleep study done? That was not done until fairly recently. It was probably, I can tell you when it was done, it was in the early 80s. And only the big universities had this, and people were trying to figure out what is sleep. And I want to give you some background on this because it's this important for you, not just your patients, but for you and for your children. This is how important this is. Paul Surratt, and I knew him and worked with him, but he actually was a pulmonologist, and he treated people in end-stage respiratory disease, obviously. And what he made was an observation. What is that the first step of? Exactly. He made an observation that his patients, when he was talking to them, that told him that they slept pretty well, that they were sleeping and that they slept pretty well, whatever, lived longer than his patients that had trouble sleeping. And so he was starting to ask questions, because what's the second step? Question. What is sleep? How is sleep affecting the long-term health of my patients with chronic disease? And what is going on? So he started a sleep clinic. And do you think he got ridiculed by people in the medical community? I can promise you he did. And now every single little rural hospital has a what? Sleep lab. And I'm going to tell you, if you don't know somebody now, if you get to live long enough, you will know somebody who you will see firsthand that if they have sleep problems and those sleep problems change, you will know it extends their life, especially ones that have chronic disease. So a lot's been done, and I know y'all think early 80s, that was like the dark ages. No, it wasn't. So anyway, but a lot has been done. A lot has been done, and hopefully more is being found out all the time, and I know that it is. But I want to show you this chart because because there's two of these in your book. This is one that I think that we could get rid of the book as long as I kept these. I would still be able to keep these because this is how profound this is. So I want you to, if you will, for me, just listen and see if this makes sense to you. What they have done right here is taken an average person they know needs 8 hours to get this kind of pattern in sleep. And what they have done in this chart is taken one of these sections and blown it up so you can see what's going on. So each of the little yellow bars represent REM sleep. The other stages of non-REM are somebody moving through those stages, first, second, third, 4 stages of non-REM. And what I want you to notice that, and I don't care that you know this is 8 hours, because some people can achieve this in 4 hours. So guess how much sleep they need? 4. Some people are going to need 12 hours to achieve this. So guess how much sleep they need? 12. But most people can achieve this in 8 with uninterrupted sleep. By the way, if you're interrupted, you got to start again, right? To really get this. This kind of pattern, though, will give you restorative sleep. So here's what we do know. That when someone first goes to sleep, and this is what I meant about that thalamus being important. People should not have. How many of you know go to sleep with the TV on? I know parents who put those on for their kids because they say, no, my kid says he has to have the TV on to go to sleep. What? Who's the parents, right? So wait a minute, what? Says it makes no sense. All right. They know that when those are going on, commercials come on, and what do we know about commercials? They're louder than the programs, right? There ends up being these different things that are waking the brain up. So we know how the environment we're supposed to sleep in. Sometimes we have to retrain ourselves for that, but we know that environment. And what we see here, and maybe y'all will see that this really is true, it takes a long time to get to the first REM. And does the first REM last long? And then the next REM will happen a little bit quicker, and it will last a little bit longer. And then longer and longer until right before you wake up, you've had a nice long REM event, haven't you? If you can get this pattern of sleep, we know that it helps with cognition. It helps with your mental process, being able to think. Y'all come in here after you pulled an all-nighter studying, and it's the worst thing you could possibly do to come in and take a test. It's the worst thing you could possibly do. So it helps you with being able to critically think. It helps you with being able to battle opportunistic diseases because we know it boosts your immune system. It helps you with appetite. People, a lot of times when people are tired, what are they doing? Overeating. And it helps you with all of those things because the brain is restored. The hypothalamus is giving out true signals about hunger and satiety, whether you're satisfied or whatever. They're giving out true signals. It affects every single part of your health. So how important is sleep? We have found out that it's incredibly important and it can extend lives. How many of you think you get enough sleep? I'm not putting my hand up on this one, but how many of you think you get enough sleep? Nobody in this room. Isn't that just sad to say? Isn't it really? What you said? Oh, as kids is your excuse. Yeah, that's a good excuse, actually. But
Do you ever get it back though? Like, I mean, once your kids get older, do you ever get that time to refresh?
The old wives' tale is that when they're little, they have little worries, but when they get bigger, there are bigger worries to worry about. Worry is a thief, isn't it? How many of you would say you're warriors? I am a real warrior. I can worry all night. Guess how much good it did? No. So I mean, I know that, and I say that to myself, and I still worry. So I think that's something genetic, and they just haven't linked it to an actual sign in the chromosomes yet, whether you're worried or not. Some people don't worry. How many of you know people who just do not worry? They just do not, and they can, you know, they're asleep before, and that's not even just making that up. Literally sleep before their head is pillow. You know, they don't worry. That's nothing they can do. And so I'm so envious of people who are like that. But I'm just saying, no, what you can try to do is do it now. Don't wait until you know, try to get your kids on a good pattern and have them to bed when the sun is setting. And they'll get up when the sun comes up. But if you go to bed too, that'll be an okay thing. You won't mind that. It's just important. Sleep's important because it can better our lives. So it can extend our lives. It means that we can be more functioning. It is really important.
So is like I have Fitbit. So is that what it calculates on there?
Yes, that's exactly what it's doing. How many others have you had Fitbit? Yeah. So they're saying that people who you'd want to, you know, the sleep is probably the biggest important thing that you're doing for your health. Because all the other stuff typically will fall into place. Look at me standing up here preaching like I do it. I don't do it, but I know that that's really true. All right, so you guys in psychology class have heard about the true person in these caves. They just couldn't figure out, they can't figure out how to survive, but they can't figure out, went through the zygomatic arch, in the orbit up into the frontal lobe. They couldn't figure out who was such a reliable worker and such a nice man, never cursed, never did any of those things, and then he survived this horrific frontal lobe injury, and his personality just completely changed. Do we know why? Because where does that all come from? Planning, personality, how you're going to react to those emotions, who you are, you know, it all comes from that. And so memory, we do know about memory and emotion, and we know that this comes from this. Sensory, where do we say sensory is? Where do we say? Parietal. We talk about vision, hearing, and touch and stuff in this, on Tuesday. We're going to talk about that. But I told you that voluntary motor comes from where? Voluntary motor comes from where? Comes from frontal. Please know it comes from frontal. And this is talking about language, you know, which many researchers and scientists feel like separates the Homo sapiens from other primates and other animals in the animal kingdom, is that we have this advanced kind of language thing. But what we're finding out, and I think it's crazy because even 40 years ago, when I was first studying science, I thought it was so ridiculous that scientists, researchers were saying that, you know, Homo sapiens were the only animal species with language. That's so crazy. You know, how many of you have dogs that know your language, know some of your words? There's animals that can know up to 200 human words. Guess how many we know of theirs? You know, so I have one of my children who's always fussing about my little dog. You know, she's so stupid. She doesn't even know what you're talking about. I'm like, yes, she does. She knows a whole lot more of our words than we know of hers. So leave her alone. Don't be
Well, I hear that. I hear that so much from my kids. They don't know what you're saying. I said, yes, they do. Don't argue with me.
Yeah, and they, you know, it is true. We don't know what they're saying, but they do end up learning our words. Do y'all remember Coco? What's it called? You know, and she knew American Sign Language. What was it? The New American Sign Language, whatever. So to say that humans are the only ones, it's just so egotistical, and really kind of anyway. So I think more accepting now that other have higher language skills, especially like whales and dolphins. We're thinking are way more advanced than we are because they're sending signals. We're actually thinking that I might be sending signals with telepathy. Have we reached that yet? No. No. So anyway, it's just interesting. Language is interesting, and I don't think it's exclusive to Homo sapiens. You know, whatever. I don't know enough about it to really talk to you. Do you see what I mean? So this is actually looking a little bit here, but y'all, this region, if you will, and here's the larynx region. And I would want you to know they're both involved in language, because even though we might be knowing what somebody's saying, do we need to communicate it and actually speak the words? Aphasia, this is a term that means a language deficit, and certainly it could mean, you know, whether you're fluent or whether you're non-fluent, language issues. But aphasia just means there's going to be a language issue, okay? So one or the others. Who's going into speech pathology? Anybody? So speech pathologists especially learn about this, because they know that when we are little, how many of you have really little kids right now? Okay, so you know when kids are little, way before they can actually say a word, they can sign it. They can sign. So if they're hungry, right, or if they're thirsty, they can say something, or like a butterfly. You know, they can make sign language way before they can make the sounds, can't they? So, so you guys know that there are different areas of the brain. And some kids, we tend, you know, in the pediatric, just what they want to happen, the milestones. They like for kids to have so many words by certain ages, months and ages, because that's what the norm has, right? And so that is important kind of to follow, because it can give you a heads up if there might become an issue. So, you know, you don't want to be all stressed about it, but you kind of do want to see that they might be progressing, because how do we learn language and how do we make sounds is by hearing. So one of the first things that might be an issue if a child is delayed is if they're not hearing the sounds. We can only make the sounds if we hear them and mimic them. I was going to say something about it, but people are going to take this the wrong way. But I just saw a video of my great nephew. Please don't take this the wrong way. I'm not meaning it this way. But my great nephew his mother is Chinese, and she's from the Mandarin part, because China has a lot of different whatever. But she's a pediatric neurologist, genius, and wonderful mother. So anyway, but have y'all heard a lot of the Asian dialects? Like, is that foreign to our ears? Just like our Southern dialect would be, so like they think we're idiots. Let me just tell you that people are bigoted about Southern accents. Did y'all know that? It is really, really true. But anyway, so I know Jean thinks that about Ben, you know, her husband is my nephew. But anyway, that adorable little boy named Noah, who right now is 18 months. And my sister sent this video to me, for me to watch and send back what I thought about it. So the video is Noah in a high chair, and he's 18 months, and he's looking at his mom, and she is saying, Noah, who's coming to see you tomorrow? How many of y'all know that? Who's coming to see you tomorrow? Tell me who's going to see you tomorrow. She's talking really fast. He's 18 months. Who's going to see you tomorrow? Who's coming to see you tomorrow? By the way, does an 18-year-old know what tomorrow means? She's a pediatric neurologist. An 18-year-old doesn't know what tomorrow means. But anyway, so he's naming people he knows. You know, he said, Mimi, which is my sister. Okay, Mimi, grandma. She said, no, not Mimi, not Mimi. Papa, he said, Papa, no, Yee, yeah. Because in her grandmother and grandfather and the sounds are yee, yay, ya, and she's saying it really fast. Yee, yeah. Who's coming to see you? Yee, yeah. And he's looking, and he's getting mad. I can see it. He's adorable, by the way. He's adorable. But I'm thinking, what is the sound? I can't even make this. The sounds are so guttural and so alike. But if you weren't really hearing them often, would you be able to mimic them? You really wouldn't. And I was feeling so sorry for Noah, because I was thinking, oh my gosh, that's just so hard. I would be failing this test too, Noah. I was thinking, give him the cookie. She was holding back the cookie. She was going to give it to him, and he could say he was coming tomorrow. I was like, what? Anyway, sorry. You know, y'all know I'm not saying that about Asian language, right? I'm just saying it's different, isn't it? Different sounds, very, very different sounds to make. And some of them sound exactly alike. So anyway, to my ears, to my old ears, maybe that didn't sound the same to y'all. I'm going to show you the video and then y'all will know what I was talking about. Oh, poor little Noah. So y'all, this is kind of old now. Even after a couple years, they think, and maybe you heard this in your psychology class. Have y'all ever heard that people are either right hemisphere strong or left hemisphere strong? Now that's not old. That's not old. That's usually true. But if you're right-handed, which hemisphere have you? If you're I said right-handed. If you're right-handed, which hemisphere? You know, and vice versa. So we do know kind of this, but it's kind of getting old because they think that where we thought it was so mutually exclusive, what was going on in the hemispheres, is kind of being thrown out because we know the brain is much more plastic than that, and different areas of the brain can take over different functions. So it's being sort of thrown out that maybe we're going to throw some of that old school thinking out. We're learning more. People are learning more and more about the brain. Thank goodness. One of our students here is at JMU now in a doctoral program in neurophysiology. And so he's really doing a lot of work now and all of this, and so it's kind of fun because he sends me some things sometimes that he thinks I'll find interesting, but I find it all interesting. Anyway, so these are, I'm not even going to ask you about that because some of that's kind of being thrown out already. Now, do y'all need a break?
Yes, please.
All right, look, and then the only last thing we're going to do, and let me tell you, like there's one chapter that there's nothing in that I'm really not going to give you anything in. So, but what we're going to do for these is simply match their 12 names with their what? That's what we're going to do. Let's take a 10-minute break. We'll come back. And that'll be the last thing we do in lecture, okay? Okay.